is an interesting idea that goes back to the early 60s. And basically, one of the things to understand about object-oriented programming is to start off with the concepts behind it. Because if you don't have an idea of the concepts, you can learn a lot of techniques and you'll never apply them properly. So the concepts behind object-oriented programming have to do with the idea of making your code more easy to maintain. If you start object-oriented programming, your code is becoming harder to maintain. This is a big clue that you're actually doing it wrong. And there are many ways to do most things wrong and a few ways to do them right. So odds are you'll probably stumble into ways of doing it wrong before you find better ways and better techniques, and then finally you'll get to where you really get the benefits of it. But the idea comes from a gentleman that worked over at the Palo Alto Research Center, and he was responsible for some of the early networking code. And networking, you have machines, and machines are connected by network lines. Okay, and you communicate on these serial ports, and eventually the serial ports turned into Ethernet ports and whatnot, and you have networking. But he was a biologist by training. And he was getting really frustrated with the amount of data that his application had. And so he just wanted the data to go away. And so he basically came up with the idea of, what if the data went away and these little pieces of code, much like the networking, much like cells, just took care of themselves. And then they just talked to each other. Okay, now when you have two actual cells in an organism, they do communicate. This cell will leak out some chemicals, and it'll drift over and get picked up by another cell. And this is like the basis of our endocrine system and all sorts of other things. It happens at tissue level even smaller. Okay? And this leakage and pickup of information from one cell to another is called sending a message in biology. So if you ever hear about sending a message in object-oriented programming, they're invoking this old paradigm of biology, of communication. Now the way that this happens in Python we'll go over. Unfortunately, they talk about it last. So I'm going to give you, yes, I know, it's the horrors of using this free book that we have. It always seems to talk about everything out of order. But when you have conceptually a class, inside the class you have bits of code attached to it called methods. And calling one of those methods from a different class is what they consider sending a message. We'll talk about methods and classes later, but first let's get into it with Python. So who had a hard time understanding the analogy? Instead of talking about cells sending messages to each other, we're going to construct our program in such a way that small pieces of the program send messages to each other. Okay, and that means that one piece of the program will be responsible for something, and another piece of the program should be responsible for, hopefully, something else. So classes and methods. Getting into Python, we've always heard that Python's object-oriented, and we've called methods on various things, like you might recall that we could do oh, it's already installed. Well, let's do this then. Okay, so we've done things like parameter. We've done things like call methods on math. For example, we can import math, okay, and then we can say math, the absolute value of 5. What was it called? It wasn't absolute value, it was floor. And so this math thing here is a kind of object, and this reference is a method on that object. Okay? So Python has these object-oriented features, and we've seen them before, but we haven't really talked about them or discussed them in depth. That's what we're going to do now. So Python programs include classes and method definitions, okay? And most of the computation that's done in Python is expressed through operations on the objects themselves. So the objects often represent things that could be in the real world, or they could be things that are useful for solving a particular problem, like you could be modeling a math problem and you might want to have an object around a variable or an object around a particular configuration parameter. And the way that the objects interact should be modeled. And for things that have real-world analogs, you want to make that modeling of the objects match the real world. For example, if you were to say purchase something, then you might want to have an order object to capture the person configuring what it is that they want to purchase. And if you were to add an item to the order object, then that means that you would probably want to have a method on that order object to add a line item to the order, or add an item to the order. Okay? Likewise, the order you would want to have, like, perhaps a subtotal that you could fetch out of it, and that would be implemented through, typically, a method on the object. Because this is the way in which people interact with orders. You interact with an order by adding items to it. You interact with an order by checking the total before you pay it. You might interact with, say, like a cash register by providing it the order that's being paid for. There's a lot of ways that you can interact. How you model this interaction is very dependent upon the problem that you're trying to solve. So do not get too hung up on whether or not your modeling of the objects is the quote-unquote correct way. The correct way is a function of the problem that you're trying to solve. And so another person may create an order object in the future that does not behave like yours because they're using it for a different problem. Okay? So over here, they like to talk about the time class that they introduced before. Who remembers the time class? Okay? So that time class captured hours and minutes and seconds, and basically it did a number of things that they talk about with times. Like, you know, we had the whole thing at the beginning where we calculated the difference between two times, and it was overly complicated because we were not using an object-oriented solution. So in this chapter, they're also going to cover points and rectangles, which is sort of a traditional way of introducing object-oriented programming, but it is fraught with lots of different implementations, and it's not the best way. So one thing that you can do is you can start off by basically declaring your class. Class time colon indicates that what is about to follow is part of the class called time. Okay? So here we are creating a new class called time. And here we have the doc string, which will be used for the automatic documentation system. But you'll notice that here on the alignment, this def is at the same line as class. Since this def is at the same line of class, this is not actually a method on the class time. This is just a regular function that happens to take a variable called time. And inside this print time, we're referencing the attributes or the fields that are within time, the hour and the minute and the second. So here we would call this by saying, hey, we've got a variable called start, and we're assigning a new time to it. We're going to set the hours to 9, the minutes to 45, and the seconds to 0. And then we're going to print time, passing in. Notice that you're not passing in the constructor, although it could be possible. But in this case, we're passing the configured time inside the variable. The variable is pointing to a time object that we just configured. A good way to mentally visualize this is using that analogy. This is our object that we made with this time constructor by saying time. Okay? And then we wanted to assign that to the variable start. Okay? And since this object is built with particular items declared inside of it, particular attributes inside of it, it has an hour, a minute, and a second. And these three things are the contents of this object. So you no longer have to pass around hour, minutes, and seconds independently. You can pass the entire object around. And this makes it a lot easier to work with your program because you basically wind up passing fewer variables or fewer values. And it's like a way of summarizing, being able to do more work. He's like, oh, well, I gave them the whole order. Well, you know, how many items were in the order? I don't know, just look inside the order object. Okay? So this print time method that they declared is over here. It's in line. So remember Python's indentation rules. Indentation means scope. This def being lined up with this class means that these two things are at the same level scope, so this print time is not part of the time object. This is the reason why it is called this way. You pass a time object into print time. Okay? If we modify the print time function to be indented underneath the class time, now this means that class time itself has a method that will take time, and it's called print time. So here, this stack, in here there is a print time function that is attached to the instance of this object. So you cannot use this print time function until you have created something. So here, it is saying, okay, we're using the time object and we're calling the print time with start. And it does the same thing that we did before, and it prints it out. But notice that right now what's passed in is the start variable. Okay? It's still the same start variable from above. For the most part, it is more convenient to focus on the start variable's behavior through the methods. And so what you do is you have a second way, which is the preferred way of writing object-oriented calls. You say, I want start's print time. And because it knows that start is a time type, it will effectively run the print time for time, passing start in as the first parameter. So these two syntaxes here, start print time and time print time start, are the same, except this one's confusing because it's referring more to the type, and it's not actually hanging the functionality off the object. By using just this different syntax, it becomes easier to rationalize. You're saying, I want start's print time. And if you were to say, assign to it something else that had a print time, you could call the other print time for whatever it is. Whatever is in start will be checked to see whether its object has a print time method in it, and that print time will be called. Okay, who's still with me on that? Because this is a complex idea for some and a very simple idea for others. And if you don't get it right off the bat, it's not that big of a deal. But it is incredibly important that you understand what's happening with this function call right here, with this method call. Because if you don't understand what's happening with this method call, you won't understand why we want to use objects. So what's inside start if we were to print it?
Hours, minutes, seconds.
What would be inside start is an object.
Oh, that's that.
Okay? And the object would be of what type? Time. Okay? And because it's of a type time, it has a print time method. Now, if I were to assign, say, an integer into start on the next line, okay, then I called start print time. What would you expect to happen?
You mean you're saying start, just saying start equals an integer, or start?
Yeah, pretend underneath this line right here, I say start equals 5, and then I do start print time.
Well, how would it look like? You say start equals 5. It seems like you're forcing it to be an integer, so it's no longer an object that has all of those attributes anymore, correct? So I think it would give you an error. It wouldn't know what to do.
So you're right, it would give you an error, because there is no such thing as 5 print time. Except that you're also made one inaccuracy in your statement, and I just want to clarify it. You said that start would not be an object, but this is Python. Everything's an object.
Well, okay.
So start would be an object, but it would not be an object of type time.
Right, okay.
It would be an object of type int.
Okay, all right, okay.
Okay, and int lacks a print time method. And so on this line, it will give an error saying, I don't know how to print the time of an int. Okay, and we'll demonstrate that real fast. And it says basically that an int object has no attribute print time. Now, I've been using the word method and attribute a little indiscriminately, okay? Because when I say a method, it's one of these names here that's got some code assigned to it, all right? But sometimes there's one of these names here that just has a value assigned to it. Okay, because I could say something like, I can't do that. But the point is that I could have a value just stored in a variable. Yes?
So you mean the method can be a variable or a function?
Right, because in Python, all of these names that hang off the end, okay, they're just all attributes. Because in Python, the name that hangs off the end, its value will be a runnable block of code if it is a function. And so the whole point is that while I'm using the word method to specify a runnable block of code and the word attribute to specify something that only has a simple value, it is fine to call this an attribute in the type Python engine. So this says that while I said that it looks like a method I want to execute, it is say it has no attribute print time. And that attribute would have a code block associated with it if this could have worked. Okay? So here we are again, and we're talking about this dot notation, which is probably the only notation that you really should be using when you're dealing with method calls in Python. Okay? And it's basically saying that they're coming up with a new vocabulary word. And they're saying that the start is the object the method is invoked upon. Okay? Or in other words, it's the subject of the method. This kind of terminology is not going to be particularly useful to you, but because they use this terminology, we're going to continue forward with it. The idea is that the print time is somehow scoped to the value of the start. The print time is not attached to something else. It's attached to the value of the start. And so he's trying to come up with some sort of vague English explanation that says that when you call print time start, okay, it suggests that the function is the active agent. Well, that's just how you type it. All right? Sort of like both this and the start print time will run the same code. But he's making an argument that if you write it this way, it's the function people read first, and since the people read the function first, that they'll think about the function first, and they won't realize that this function is actually a feature of this start variable. And so he's making the argument that to make your program easier to reason about in an object-oriented manner, you should actually call it start print time. And this aligns with what I said before. There's really only one way that you want to write this if you're doing object-oriented programming, because you always want to think about the object that you're operating on first, since it scopes out where this print time will be defined. Okay, and he's got a little exercise there, which is rewrite time to int.
Could you go back to that bad way of invoking the print time to show what the undesirable way?
Hello, Edwin here. Okay, could you come up to the fourth floor, please? Thanks, bye.
10 o'clock.
So this quote-unquote bad way is the way that it actually works under the covers. So to say that it's bad, as in like inferior, you're going to wind up using this either way. But the point is that this syntax here makes it easier to reason about the program. Much in the same way that, you know, there's two ways to write an English sentence that expresses the same thing. One syntax might emphasize certain things, and another syntax might emphasize different things. And so this syntax with the variable and then the method off of it emphasizes the objectness of this variable, and that you're doing a print time on the variable. This way, start might not be an object. It's Python, everything will be an object, but start might be like the number 5 or a string or something, and you won't really think of it right off the bat as like object. You could think of it off the bat as like the same way that you might write a C program that lacks object-oriented programming, or a Fortran program where you're just saying I've got a bunch of functions, and as long as we call the functions in the correct order, the program is done. You know, so let's go through again and let's start talking about the increment, which he has added to time. So he's saying that inside of class time, which means that you have class time somewhere up here for real, and you've got def print time because we already established that. Now you've got this new method called def increment. Okay? An increment takes two variables. One that they've called self and one that they call seconds. Okay, now Python's loosely typed, so self is just a word. It's not a special magic anything. It doesn't mean that you have to have a certain kind of object in there. But because we're going to call it using the object.increment, and because that format effectively maps to where the object is the first thing that's passed through, this start increment is going to function as a time increment start 3251. Because I said that one's just syntax for the other, this is the reason why this has two inputs. This start is the object, is the variable holding the object we're currently thinking about, the one that is the subject in his terminology. And it is going to be passed in to this position. So the self variable will be what was inside the value of start when it was called. And if you ever want to create a new object-oriented programming language, this is the pattern that almost all object-oriented programming languages eventually adopt. They just don't necessarily show it to you on the surface. Sometimes you have to get into the language's implementations to find it. So, who has a hard time understanding why increment takes two variables? Pizza guy's coming, so if you close the door, he might not recognize we're here.
The increment, it can only work upon an object. In the way it's set up, it can only...
Yeah, I mean, if you passed in other things that are not objects, then basically this thing would fall apart. Okay? But that's the problem with dynamically typed languages. Instead of getting an error at compile time that you're passing in something that's the wrong type, you just run with it, and hopefully all the types are correct and the developer has made sure that that's what's happened.
You talked about this issue of dynamic typing. It seems like a couple of things. One, you don't get error messages, or obvious error messages. But I guess does it also make it, we always talk about this, how difficult it is to reason about programs with dynamic typing, also make it more difficult to reason about things?
So this goes into a little bit of computer history, okay? How people reason is much more of a function of how they reasoned before. So whether they're going to say it's more difficult or easier will depend upon how many new things you're asking them to do. For example, we have all added numbers plenty of times. And so if I say, is addition an easy or difficult concept? Most of us will agree that it is an easy concept. At the same time, some of us may have young children, and addition is not as easy a concept for younger children until eventually they get enough experience with it. Dynamic and static typing is a very hotly contested area. Oddly enough, the two camps that promote dynamic typing and static typing pretty much came to a resolution in the early to mid 1980s that static typing had won. Okay? The reason why is because they had known for a fact that it took 30% longer to write statically typed programs. So you would think that dynamic typing would win because the business pressures would make people want to get their programs to market faster. But that actually didn't happen because the amount of time to verify a dynamically typed program was actually correct under all the different situations was so much higher that people were willing to pay the 30% longer time to write it up front. Now, there are a couple of places where programming languages, due to various reasons of accident in history, managed to become super popular. A good example is JavaScript. It is the only programming language that runs in any web browser that you can guarantee is going to be there. There are a couple really weird one-off web browsers that will run more than JavaScript, but JavaScript is the baseline that's in every web browser. Because when JavaScript was created, and because they wanted something that was really simple that didn't do a lot of error checking or compilation, JavaScript was dynamically typed. And so they just didn't have types on variables. Whatever you stuck in it was whatever it was. Okay? And so this means that the dynamic typing camp sort of has gotten a second breath of fresh wind as JavaScript has become an incredibly popular platform to program for. Not because it's a great language, although some people do believe it is a great language and their opinions are fine. But mostly because it's the only way to succeed in a web browser. And so we're seeing a shift where dynamically typed languages are being revisited after being mostly decided that they weren't worth the effort. And Python is dynamically typed, but Python has one thing going for it that some languages don't, which is Python is also what's called strongly typed. So in some of the dynamically typed languages, they didn't actually do any type checking even at runtime. Python does, and that's where the strong typing comes in. So I think this is a good time to take a small break so we can all get our food. And I would like to go through this example real fast before we do that. So here you can see that the object is passed in as self, and some number of seconds is passed in. And of course we have that time to int function, so we're fetching the time out of the object in some number of seconds that we added to what's passed in. Because this is the add to assignment operator. Okay, so it's not just setting the time to int to seconds, it's also adding it to the previous value. It's not a straight initialization, it's an increment initialization. It's an increment, basically. And then we're using int to time, which will take the seconds and convert it back into an object. Okay? And so that way we have somehow shifted the time in the object by using this intermediate integer of number of seconds. And so here we see how this would work. We'd say start print time, and then we'd say start increment it by a very leet number of seconds, and then we print the time on the end. So here's the start. We increment it. We get an end object, which represents the time offset, and we print it. And so in this example, we have two different objects, a start and an end. Okay? Yes?
What did you mean by leet number?
This is a leftover from a really bad internet slang called leet speak. And so you were elite. L-E-E-T.
Oh. So inside joke.
So it's an inside joke that apparently is too inside to even be a joke anymore. So.
We're too old.
Thank you, or too old, as a person who might actually be older than me says on the back row. All right. So this positional thing here, if you try to call this start increment, you'll see that even though we defined it with 2 parameters, it doesn't work. And the reason it doesn't work is because one of those 2 parameters is the self. And so when we call it with 2 parameters with the correct object-oriented notation, it takes this start and it shifts it to the beginning, and it'll say, hey, it takes 2 parameters, but you gave me 3. And this is a leftover of the actual implementation details. Sorry, I need to let our pizza driver out.
Sorry.
No problem. Okay. So we talked about why this gives the 2 positional arguments when 3 are given, because there's the implicit argument that is the start that is passed in at the beginning. And so here, when we talked about positional arguments, and you remember that there are arguments that are actually parsed out by the position in which they are passed. This is positional, but this, due to the fact that it has a keyword and a default value, this is a keyword argument. Okay, and so it's treated by Perl slightly differently. I don't know why he decided to make a point about positional and keyword arguments right here, right now, but the object will always be passed in as the first positional object, positional argument. So let's get into the more complicated example, where we're actually going to do a comparison between 2 times. And I'm not really clear how this is more complicated, because all we're doing is we're saying that we're going to operate on ourselves, and we're going to take a different time object. We'll turn them both into integers, because the integers was the number of seconds that was represented, and then we'll do a comparison to see if the other one is smaller. If the other one is smaller, then basically it's going to be, this one is going to be a bigger time, and then you'll hopefully get the right result back, except that almost seems backwards. Oh, no. They're relying on the reading. So like end is after start. Okay, and so they're trying to do like a full English thing inside the programming language. So no, this is correct. So and then of course he says it almost reads like English. Well, it does if you program it that way. And you should make your programs clear, but you shouldn't be shooting for, say, perfect English grammar. Okay, so we talked about methods, and we talked about objects, and we talked about how they get passed back in so they work. But one of the things we didn't talk about is how do you make a new object? So we saw up there before that they had this time, and then they assigned it to some sort of variable. Okay? But how does this create a new object? I mean, not all objects are the same. Some objects have features and properties in them. Some objects have behaviors that need initialized, so on and so forth. The way that this happens is this is called a constructor, and you'll notice that the format of it is such that you're using the type of the object as a function. Okay, so time was the actual class time. All right? But we're using it as a function. Well, when that happens, you need to allocate some memory, and Python takes care of the memory for you. And you need to basically initialize and set up the object, and Python takes care of calling the stuff to set up the object for you. But it doesn't know how to set up new objects because they're new and Python's never encountered them before. The part where it passes control back to you, having an ability to program it, is done through a function called underscore underscore init underscore underscore. And this underscore underscore name underscore underscore is a special class of functions that are always defined, and they're called magic methods. All right? Now, these magic methods, there's nothing particularly magical about them. They can be called normally. A lot of things can happen with them that are normal, but they are defined for every object in Python. So you can basically call the constructor for an integer. All right, you could do it. I don't know why you would want to do it, but if you did do it, it would look something like this. Note there's a dot, then there's underscore, underscore, int, underscore, underscore, 5. Please don't use the number 5 this way. It'll be confusing as anything to anybody. But the point is that this is the type, this is the reference of this is the, the attribute that holds the initializer, and then there's the parameter. Okay?
But isn't a class instantiated when you, what do you call it? Give a specific case of it. The class by itself isn't yet instantiated, is it?
Okay.
And yet it has in it, but are they using instantiated in some different way? Or?
No, you're using the word instantiated in a way that's not compatible with the way most programming languages use it.
Oh shit.
Okay, so think of the class. Think of the class as the blueprint.
Yeah, right. And it's instantiated when you create an actual concrete, living, what? Representation of it, or instance of it, instantiation.
You've got the right word. Okay? But let me try to explain the difference. There's a relationship between classes and what we call instances.
Yeah, yeah.
And so a class would be the actual text of this class time. You bet.
And it can exist without any instantiations yet, right? It can exist sort of all by...
Well, when I'm trying to clarify the word, it helps if you stop using it, because I'm trying to get to a point to where I can define it a specific way.
Okay.
And every new use, it adds a new coloring or idea behind it. So what we're saying is that the class is the text. It's this blueprint. Now, when you construct a new one, you don't instantiate the class. You create an instance. You instantiate a new object. So instantiation is the process by which you create objects. You don't instantiate the class, you instantiate the object. Or you create a new instance. And those are the two ways to use the terminology. So that verb that you're using is not attached to the class, it's attached to the object. Okay? All right. And you're absolutely right. Instantiation is something that object-oriented people talk about all the time. But you're instantiating the instances, or you're instantiating the objects.
And fuck English.
No, it's not fuck English. It's much in the same way that some people will use the word, oh, he learned me well.
I didn't mean to start it.
But the point is that this kind of inversion is just not the approach. It might even be colloquially more common to say that in some places. Okay, but it's not actually the way that we use this word in programming.
Okay.
Yeah. So here you can see that it's initializing. It takes itself in the hour and the minute, second, and here it's saying that it's basically going to have an attribute on self called hour assigned to the value passed in hour. Notice the difference between these two. This one is very clearly scoped to the self object, whereas this one over here, it is not scoped to the self object. So it will bind to the parameter list. So this says that the hour that they passed in is now going to be stored in the object's attribute hour. Likewise, the minute and the second. Okay? And so over here, they're going through and they're discussing how, like, you know, this hour and this hour are not the same location in memory, even though these two things share the same name. Usually, like when you use the variable x, if you use it again, it's the same variable x. You assign 5 to it, you print it out, it'll print 5. But since this hour is scoped to the object, then that means that as you get a new object in self, this hour goes with the object. It's the hour that's inside that model up here. And self is just the name that's pointing to a specific current object. Whereas this hour over here is an hour that's outside of the object. So who is confused about that? Anybody, or can we move on? You're confused about it? Okay. These two names look to be the same because they have the same 4 letters. Hour.
Okay, that's, like you could earlier, you could have said hour equals assigned value to that variable. And
right.
Self in the context of, okay.
But putting this self period before gives it a context that indicates that this hour here is the hour inside the object. And this hour here does not have that context, so is an hour from somewhere else. Okay, so here we are talking about time again, and some parameters are optional. So here's time print time, and we get 000 because basically we called time with no arguments, and remember it was based off of the number of seconds stored internally, so that would be 0 seconds, so that you get 000. Whereas here if we call time with 9, and since 9 is a positional parameter, and the first position was hours, then when we print it we get 9 o'clock, this is 9:45. Between you and me, this is not the really great way to create a constructor for an object because you don't want it to mean radically different things based off of whether you pass it 2 or 3 things. For example, in order to pass in, say, 35 seconds, someone would be tempted to type in 35, but that would be 35 hours. It's a lot better if you use either the position,
default.
Thank you. The keyword arguments. It's a lot better if you use the keyword arguments in order to pass it in. Okay, and so then, but there, you notice that they wrote this whole print time thing. It's kind of unusual that they wrote this print time method to display the time because Python has a built-in magic method for printing anything, or actually for formatting anything. And that's the str method, __str. str is a shortening for the word string. It's supposed to take your object and print and return back a string representation of the object. Who here has ever used Java? Awesome. Java has toString. Most languages have this concept. It makes it really easy to display something when you're just a developer trying to reason about your program. And so when you print the object with the global print function, print, this time will represent back to the class time, and then the class time will see whether an __str__ is defined. And then that's the code that will be ran. So here, he's basically overridden the string magic function by putting his own copy of what he wants to happen here. And now we no longer have to call time.print time. We can just say print the variable name, and it'll delegate to the __str. Now I glossed over that and kind of went a little bit fast because I thought everybody was following along. But is there any confusion about this? Yes?
If you don't define it, is there a default definition?
Yes. The way that these magic functions work is all the objects in Python eventually inherit from one root object, the object, if you will. And that root object defines the __str. Now, it probably won't print out anything that has to do with the data the way that you want it. For example, here we're formatting the hour, minute, and seconds into a colon-delimited string of 2 digits each. You know, so it's 2 digits for the hour, so you get the 0, 9, 45, and then 0, 0. All right? This is very specific to the time object. But if we did not define this, it still would work. It would just call the parent implementation of this in the object, if you will. Yes?
So how do you figure out what the magic methods are?
There is a very large list of them. But you can also use that utility for asking what it is that you can do with an object. Okay, so what was that help command that you're so fond of showing for? What's the help command for object?
Help. I'm helping them whatever object they're looking for.
So here's class object. It's the most base type. I mean, apparently they didn't bother to say anything more about it.
Right. That's because object Python doesn't do anything. All things are sent from it, but it doesn't actually have anything.
If you do dir, it'll show all of the magic ones in the beginning.
Yeah.
dir, and then parentheses, whatever you want. You gave it an actual object.
Okay, and so here you can see that we have some of those magic methods defined. And of course it needs to have the ability to create itself, so there's an it. Okay, and then like the greater than, not equal, less than, and so on and so forth. Okay? So here they're talking about how to implement the string representation, which, you know, just for fun, there it is. Okay, and so we're not going to be using the object string representation. See, if we do print 5, then it would delegate to 5's. Okay, it's invalid syntax, but it would delegate eventually to 5's string. I think that might still be invalid syntax, but it's nope, that's valid syntax. So here you can see that this is basically it's taking the int type and it's calling the __ strings method on it with the parameter. This would have been the self parameter of 5, and it returns back a string containing the character 5 as opposed to the number 5. Okay, so you can overload that. You can basically start changing the behavior of Python's functions. Now, some programming languages have operator overloading and some programming languages don't. But operator overloading, if you've never ran into it before, is kind of an interesting way in which you can change the behavior of operators. It may have been a while back, but we talked about operators. Things like the plus sign. When you do A plus B, they operate on both of these variables and will return back some sort of result. Okay? It is possible to change the behavior of the plus with something called operator overloading. And the way that this works is that it takes a look at the first object's type. And so it would say if A is a type of, and let's just say A is a type of, I don't know, airplane. then what it'll do is it'll say airplane underscore underscore add, and it'll say whatever that value of A was, okay? And then whatever this value of B is, and it'll run that function. And so like if A was an airplane and B was a passenger, you could come up with a really kind of funky looking system where you could add passengers to airplanes. Operator overloading should always be used with care, because most people who see this plus sign will think addition. And addition comes with all sorts of rules. Like, I could easily switch it around to where it's B plus A and I expect to get the same thing. Okay, but that won't work when you've overloaded an operator. Okay, because I didn't define that that airplanes could be added to passengers. Okay, this is the reason why some languages don't have operator overloading, but Python does, and so you need to understand it and understand how it works. But it is definitely one of those tools that you should use very sparingly. Occasionally, it can be used to great effect, like if your variables represent matrices, or if your variables represent some sort of complex numbers. You could just simply define a complex number or an imaginary number into the variable, and then that way you can just use the regular math operations. But occasionally, you know, but there's very limited areas where it feels supernatural. So don't run out and like start trying to use operator overloading for all of your business rules and logic and stuff like that. But the point is that it can be used very effectively. And so here is what it looks like if you wanted to add times together. You would define this underscore underscore add. Of course, it's got to take itself because it's a method call. And it's got to take something else. And so here you can see that it's going to convert the time into the integer, the number of seconds. And then it'll convert the other thing into the number of seconds and adds it together. And then it will return a new object constructed off of the sum of those number of seconds. And so here we can say that 9:45 and 1:35, if we add them together, we get 11:20. Okay? So it's really cool stuff. But what happens is eventually you will open up this program and you will forget that start and duration are times. And you'll be like, well, wait a second, how did I get this thing when I just added two numbers? And so it should be used sparingly. Now, the way that this works, though, is the same way that we talked about how all of the other things. It's doing typed-based dispatching. It's dispatching based off of the contents of the variable and the variable's type. So you'll remember that way back when, on the very first class, we exposed you to that type function. If you said type 5, it printed out int. Remember? So this is how it finds. It doesn't actually run the type function. It doesn't need to because it's got internal shortcuts. But this is how it knows what type it's going to be looking for, an overridden underscore underscore add. And so since it's type-based dispatching. So here, notice that this time to int was an integer and this other time to int was an integer. So this addition does not go up to this add because this is an integer plus an integer. All right? But when we hit the add, the plus operator with different types, here's the time in start, here's the time in duration, start plus, it will dispatch dynamically to that underscore underscore add. Now he uses a phrase polymorphism in such a way I have never used it before, and I would almost argue that he has used it in a way that is not according to any definition I have used before. He says that polymorphism is type-based dispatching, and that basically the fact that you can do this sort of overloading here means polymorphism. I've never recognized that definition before, so I'm going to give you an alternative, probably more popular definition. Polymorphism requires one thing called inheritance, which is he'll cover later. So he's kind of putting the cart before the horse. But the point is that polymorphism is whenever calling one method. So let's find a method called, okay, this add time method depends on the value of self. So if you have 4 or 5 different things that you could add time to, like maybe one of them's a payroll chart, and the other one's another time, and the third one is a bus schedule or something like that, and this add time works, and you have no idea what's inside the self, that's polymorphism, because it will dispatch to the correct instance that was stored in that variable.
Because, so another way to say it, it figures out the appropriate context.
Right, you passed it the context implicitly by the contents of the variable.
The object, yeah.
And then it goes and it checks that, and so it'll say, let's say A was, in my example, I think it was an airplane. And maybe an airplane is a vehicle. Maybe a vehicle is a moving thing. And then a moving thing is an object. Because everything eventually is an object. And so it'll say, if we did something like a.move, then it will say, oh, okay, is there an airplane move? Is there a vehicle move? Is there a moving thing move? Okay. When all of them share one definition, like if we just put the move and moving thing, then you're not going to see polymorphic behavior. But here, we could also make a bus a vehicle. All right? And when the move comes out with different behaviors based off of the bus, like maybe the airplane prints flying to destination, and the bus prints driving to destination, that difference in behavior based off of what we stored into A. If we store an airplane into A and we get flying, and then we store bus into A and we get driving, that difference without specifying what type this was is polymorphism. Because you have basically many possible solutions to the same question.
The way you set that up, you talked about inheritance, so vehicle is built, it basically says take everything, all of the objects and attributes and methods and moving thing, and incorporate all those, and I'm going to give you, when I define vehicle, I'm going to add to that.
So a deep study of inheritance and how to do it really well probably will exceed the amount of time that we have allotted to it. But for right now, since he put inheritance at the end and I've kind of let the cat out of the bag, just think of this tree as ISA. An airplane is a vehicle. A vehicle is a moving thing. And a moving thing is an object. Okay? And so, likewise, a bus is a vehicle. But that also means that the bus, through being a vehicle, is also a moving thing and an object.
But it seemed like they wouldn't inherit this move operator. At least it's not the same.
They would if the move operator was declared here.
Well, that's what, okay, all right.
And then inside class moving thing, if you had a def move, then that means that an airplane could not be considered a moving thing unless it had a move.
Right.
Now you could put your own special move down here and hide the parent definition of move.
Okay, you override it.
And that is called overriding.
Yeah.
Okay? But you could never get rid of this move, because if you erased this move down here, you would just wind up delegating to that move. And so this sort of ability to override the behavior based off of the bottommost object that you could be considered one of in this tree, that's what makes polymorphism work. They chain up the tree looking for implementations. And so if you start here and it has a move, my marker seems to be going out, but if you start here and it has a move, and you start here and it has a move, then these two moves could possibly be different.
Sure.
And that's how, but you know that all moving things has a move, so you know you can safely call move because it's a moving thing. And even though you may think that you're calling move on a moving thing, what's going to happen is it's not going to start that function calls evaluation here. It's going to start that function calls evaluation at the actual thing that was constructed and move up in trying to find an implementation.
And once it finds when it stops.
Once it finds when it stops.
Just real quick, is JavaScript not full polymorphism?
It depends heavily on how you use it. JavaScript objects are very sparse, but since they are effectively dictionaries of names to lambdas, or names to nameless functions, when you override one, you have a tendency to replace the old implementation. And so this is how you're guaranteed that you're always calling the bottommost one. And yes, there are exotic ways you can do it even crazier than that in JavaScript, but you know, we like to promote good patterns in JavaScript as opposed to the really bad ones. So this type-based dispatch indicates that when they call this add will invoke the add time. Now, which add time will it invoke? Well, it's going to invoke this add time on the self. So it'll invoke it on whatever the type was before, and then that means that it'll actually stay within the class time. I do not understand why they decided to declare basically the same function twice, except that they were basically trying to show that you can dispatch to different types of functions based off of the type. So here it says, if the other is a time, then use add time. But if the other is not a time, then increment. And the reason why they're trying to do that is because they're trying to basically overload this call. Overloading is another one of those vocabulary words that goes back to the old days of object orientation, and it actually exists outside of object orientation too. But it used to be that when you wrote a function, and let's just call it, do it, for lack of a better name, and you passed in a value, remember the static typing days that we referred to? You would pass in a very specific type. You would pass in maybe a string, okay, or you could pass in a number, or you could pass in one of the time objects, okay? But the point is that there was a trick where you could have multiple do-its defined, and one would be defined for, and remember, this is not going to be valid Python now, because I'm going to pretend like Python takes types. And so you could say do it string do it int, and do it time. Okay? And you could write 3 different implementations of the same function. And based on what you would pass, it would actually look at the type and call the correct implementation by matching the type. Okay? This is a neat trick, and people were very excited because sometimes when they pick these names for these functions, they pick much better names than do it, and they want to use the same name over and over again. But this kind of function that takes variable types in there is harder to reason about, because you might accidentally misread something like that, and if the behavior is wildly different between do it the string 5 and do it the number 5, you won't notice that until you have spent a lot of time trying to figure out why your program's not running the way that you thought. Because this is visually so similar to a number that a lot of people just don't notice it right off the bat. They will eventually notice it because of practicing and debugging. So you've got to be careful with operator overloading. And here what he's saying is this other could be a time or it could be something else. And so this pattern does show that you can use the variable type with isInstance. Is other an instance of time? Okay? But the entire approach of checking things by using isInstance is fraught with harder to maintain code. Okay? It's usually done once to start off what you think is easy, but it's one of those traps where it gets harder the longer that you do it. So here he's basically talking about how he has now cleverly managed to say he's got his start and overridden add to add a duration time, but he also has a start and his overridden add to add an integer time. Just an integer number of seconds. Okay, and so this is how he's managed to get his overridden add to handle things. But then you'd say, oh, well, you know, it's add, right? I can swap the parameters. And suddenly when you swap the parameters, everything will break because nobody knows how to add a time to an integer because the integer doesn't come with an overridden underscore underscore add for times. So Python has another built-in, okay, another magic function called radd, which is the right add. Now the terminology may seem very odd, but I'll just tell you what they mean instead of trying to provide rationale behind it. Here on A plus B, the plus operator, if overridden, will resolve to the left variable. Okay? If it's not overridden, then Python will check the underscore underscore r add. I'm going to get a new marker because this one I think is giving up the ghost. Let's try red. It'll call the underscore underscore r add.
Much better.
I'm glad to hear that. Let me redo this too. So if it doesn't know how to add this type to this type, then it will try the radd override on this type, the right object. And if the right object has an radd, then it will call b underscore underscore add a. Do you see how that works? Think of radd as the opposite operator overloading for when you want this type to be the one that's checked. Now, if you have this type being checked and this type being checked, you might wonder if both of them are overridden, which one runs? Because obviously you can't run both of them. And the answer is it will first attempt to call the __ add on this one, and if an exception is thrown because it cannot work, then it will try to call the __ r add on the other one. Who's following me still?
Sure. But it's,
I saw one
I was
hand
going to
go
say,
up.
it sounds like this is like something you'd want to avoid. It's hard to imagine a use case for either.
You're starting to see why I said that it's important to understand operator overloading,
Yeah.
and also probably equally important to use it incredibly sparingly. Okay, so like this is something that you'll want to understand because it will be the kinds of things that people will sometimes ask in job interviews in order to determine how wide your knowledge of Python is. But this is not the kind of thing that the same people who ask will want inside their code base. And so it becomes one of these useless points of trivia until you truly need to use it. And you'll find that a lot of things about computer programming, if you're getting into the field, you learn a lot more than you actually wind up using. Because that one day when you need it, it saved you weeks of work. Okay. So here we are, and he's basically saying, he basically said the same thing. Here he used r add in time so he could put the number in the front. And if you're going to override add, a lot of times it's appropriate that you override both add and r add and a number of other math functions so you can make it all follow the rules of correct algebra. And so usually if you override one, you find yourself caught in a trap where you have to override multiple of these built-ins to make all of the math work out. Because remember, you've got the basic rules where, of associativity. To make sure associativity works, you've got to override add and r add. Okay? To make sure the commutativity works, you've got to actually write tests for this stuff. Because if you don't write tests for this stuff, eventually then what will happen is you'll forget to override one of the things that's needed in one of the conditions. And someone will, of course, naturally use that condition first and cause an error right away. That's the pessimist in me. So polymorphism. We talked about polymorphism before, and he's saying it's type-based dispatch, and it is type-based dispatch, but it might not be necessary. Okay, and he says that you might not need to do type-based dispatch if you write functions that work correctly for arguments with different types. Now, arguments with different types ran into that example of the string 5 and the number 5. That I'm referring to before, but isn't actually up there. The point is that arguments with different types creates its own can of worms. So I'm not actually sure that this is a strong and valid argument. Most people can understand polymorphism much more easily than they can a function that, performs one operation but can take, a cat, a parrot, and 3, mariachi players or something like that. It's the overridden types thing is a different approach to the same problem, but generally speaking, it's a less maintainable. That said, we're going to get into it deep, and he's going to create a histogram function. And so first he creates a dictionary, all right? And then he's going to say for every item inside whatever S was that was passed to it, if this item is not inside the dictionary that we defined, then add it to the dictionary with a value of 1. Okay? And doing this, he basically adds it into the dictionary the first time. Now, histograms count the number of occurrences of things. So This is the if statement, and it's broken a little bit here, but otherwise, down here, if it is not in D, I'm sorry, we add 1 as the value, but if it is in D, we would drop down here, and we would just increment the value for that particular key in the dictionary. All right, so can you see how he's using a dictionary to build a histogram? All right, and then he says that you return D, and that would return the dictionary. And so here he is, he's defined an array of spam, egg, spam, spam, bacon, and spam. And if you're not familiar, it is Python, named after Monty Python, and this is part of the famous spam skit, where basically, eventually, everything starts getting more and more spam. They start talking, and then spam gets interjected, and spam gets interjected more, until finally you're getting down to, like, 80% spam by word count. So the point is that this histogram shows that bacon was in there once, egg was in there once, and spam was in there 4 times. So functions that spam work with several spam types that are called spam polymorphic spam. Polymorphism spam can facilitate spam code, spam, reuse, spam, for spam, example, the spam, built-in spam, and so on and so forth. But seriously, the point is that he's saying that if the function works with several types, it's called polymorphic. This is not a normal definition of the word polymorphic. A normal definition of the polymorphic would be if the function exists on possible different implementations with different code for the different implementations. You have 4 or 5 instances, and you're calling the same function off of it, and the code could change based off of which instance you're using. All right? This is typically known as operator overloading. Here he's saying that you can pass in strings, but this would work just as well with numbers. You could pass in 5, 6, 6, 7, 8, 9, 10. And then it would say that each one of those was used once. Oh, okay, not 6. 6 was used twice. But the point is that polymorphic in this term means differently than what you've learned in other object-oriented languages. He's using the word for both polymorphism and for operator overloading.
Could you repeat the street definition of polymorphism? The normal one?
The normal definition of polymorphism is when you call a method on an object, it could resolve to a different implementation based off of how that object was constructed. So in other words, if you say called the str method on time, you get a formatted time. But if you called that magic str method on an integer, you get a formatted integer. That's an example of polymorphism from the sort of mundane point of view. Okay? Yes?
I was going to ask about that. What decides to get the correct format when you call that magic str?
So it looks at the type that's stored in the variable. So the variable has a value, but all values in Python have a type. And so it looks at what's stored in the variable, and it will see the type of that value. And that will determine which str is the one that is used as you go up the tree of inheritance. So here, let's do this. Remember that we said that the type of everything in Python is an object, right? Okay, and then we had that time. Okay, and these are types here. And so then we say start equals a new time, and we'll initialize it with some number. It doesn't really matter what the number is right now. Okay? When you do say something like print start, okay, this will do start underscore underscore str underscore underscore. Okay? Which will look like, since start is a time, it will look like time underscore underscore str underscore underscore start. All of these things are equivalent. There are different ways of writing the same thing that's going to happen. Now, if this str is defined in here, so we have class time colon colon def underscore underscore str self and some code. Then when it starts trying to figure out how it's going to call this str, it'll run into this definition. But if this definition was not written, then as it tries to do that, it'll say, well, you know, time is an object. So does the object have a def str? If I can't find it at the time level, at the more specific level, can I find it at a more abstract, more generic level? And it keeps going through each step of the more generic until it finds an implementation. If it gets to the top and it doesn't find an implementation at all, then it will say something like underscore underscore str is not defined for this object. All right? But it doesn't have to be written inside the class time. It could be written in any of the parents. Okay, does that make sense to you a little bit now?
Yeah, it's branching out.
Yeah, and so like it's sort of like, well, we'll take it and we'll treat it like the most specific thing that it is, and if we can find it there, great, we're done. But if not, we'll treat it like the more generalized version of it by moving one step up this object hierarchy. And then finally when we get to the top, if it's not there, then it wasn't defined anywhere.
And is that behavior can be called inheritance, or do you think that's going to be a separate definition?
The searching for something through this object tree is called dynamic dispatch. Because if you change the value of start, it changes where you're crawling your way up to the object. If the next line is start equals, you know, house, and I have a house constructor, then it won't start at the time, it'll start somewhere where there's a house and crawl its way up towards the object. And so since the contents of the variable can be changed, calling the method relative to the variable changes with the contents of the variable, because it changes which path you're going to be searching for this method through. That's called dynamic dispatch. Okay, and so it has its own name. And unfortunately,
are we getting the polymorphism thing? Because you can, if you're not getting the details of the definition, you just think of it like this. If you have a function that's supposed to operate on something, everything has a type, or should have a type, then that something that's doing the operating has to have a way of handling those different types. If it can handle those different types, it's called polymorphic. That's what it means, right? So if you're using a language that doesn't have inheritance, and you have no concept of objects or types and subtypes that are arranged in a tree like this, that inherit from other types, you could essentially just create a function, and you can override that function to accept different types. That's one form of polymorphism, because now all you do is you call that function, and whatever you provide that function with, the system knows if it's an integer, what I need to do is I need to do string repetition. If it's an integer on both sides, I need to do multiplication, right? For the asterisk. You can implement polymorphism in that sense, and then to the user, when the user sees it, he knows that calling that and providing it, either a string or an integer, is going to result in either replication of that string or multiplication, right?
Now using Evan's, I just want to clarify, because we talked about operator overloading and polymorphism as separate things. Evan's using the definition of polymorphism that's inside this book, which is not the one that's shared with other object-oriented languages. Basically, he's saying that any kind of multiple dispatch, any kind of operator overloading is polymorphism. And it can be perceived to be that way. But some people get particular about the terminology. Certainly, polymorphism is anything where this might return back something different. Anything where you have variable dot sub. If it's possible for this to return back something different based off of the contents of A, you clearly have polymorphism.
But what I'm trying to get at is that the idea of polymorphism is just that that function is accepting different types and it knows how to operate with it. The implementation of it is going to depend. Some languages have objects. They have their types arranged in a tree like this. They have inheritance on their types. Those types of systems have different mechanisms for handling polymorphism. You can get into different names for it. You can get into what is polymorphism and what is. That is all going to be dependent on what that language provides. So you should just say, okay, does this know how to handle multiple types? Yes. Then there's something polymorphic about it, right? And you can get into what is the different types of polymorphism. There's Wikipedia pages on it, which is pretty entertaining and interesting. But the idea of polymorphism, operations work on different types. The same operation can work on different types.
So let's get into the interface and implementation commentary, which he has, which is basically the idea that you should kind of hide how you do something behind an interface. And that, it's just basically a protection method for when you're developing code. If you expose how you do something, then it becomes very hard for you to change how you do something. Okay? But if you say hide how you do something behind a method definition, then you can easily change the interior of the method definition because everybody's just calling the method. They're not actually worried about the specific steps. So a good idea, I don't like his example, but a good idea is that you basically, if you name the methods on how you're going to use the object, it's a lot easier to hide what you actually do. You know, if you've got a flight and you want to book a ticket, and that flight object has a book a ticket, method on it, you don't need to know how it got booked. You just need to know that it's inside that flight somewhere somehow. And that makes it a lot easier for people to use it. But if you start looking at the object and the object starts looking like flight open database connection, flight find flight number, flight do this, and you start putting the exact implementation in different methods in your object, then that means that nobody will use your object correctly unless they call all of those methods in the correct order. And then that makes it very hard to maintain your program. Okay. So now we're getting down to something that we're going to wrap up with. There is another extra chapter with the goodies. It has a lot of really cool stuff that makes Python uniquely Python. All right? But this is the last part that you actually need to know in order to have a quote-unquote fully rounded ability to use Python. And that is inheritance. And you can tell because I said that I kind of got confused why he put polymorphism at the last and why he wasn't talking about inheritance before and all these other things. Why they were out of order. Generally, inheritance is presented beforehand when you start talking about polymorphism. And since it's presented beforehand, that means that it felt really odd to try to talk about all this dynamic dispatch and the type hierarchy and stuff without mentioning it first. But the point is that he's going to make this card object, and then he's going to make a deck object. So this card represents a standard playing card. Most of us have dealt with them. There's 52 in a deck, usually, unless you're playing with a stacked deck. And if you are, don't invite me over for money. So here he's basically indicating that you can construct a card. Remember, he's defining a constructor with the init method. And he's saying that the suit will initially be 0 and the rank will have a default of 2. And that's because he's going to decide, I don't know how he decided it, but the clubs naturally map to the number 0. And,
The
you know,
lowest.
the 2 of clubs, yeah, I can sort of see the 2, okay? It may be lowest, but there's so few times where you actually have to order the rank that way.
Unless you're a poker player.
Unless you're a poker player and you've got really incredible luck and people are pulling out the exact same hands with only differences in suit. So anyway, and so the queen of diamonds is, apparently diamonds is 1, and then the queen will be 12 because, of course. And then he's basically said that he's got rank names and suit names, and you'll notice that these are very cleverly ordered arrays such that the 0 lined up with clubs, and the diamonds lined up with 1, and the hearts lined up with an index of 2, and so on and so forth. And likewise, the queen has an index of 12. Remember, we're dealing with indexes. So that means that they're not going to be the count number, but rather the offset number. Okay, and so he's saying that now I can print out an English reading string by basically saying the rank, okay, using that as an index on the rank names, the suit, using that as an index on the suit names array, and so now I have 2 strings, and I will use the formatting operator to say the king of spades. Assuming that I had those values in there. And so what you'll notice, though, is that he has defined suit names and rank names inside the class card. So, they're indented in. That means the suit names and rank names doesn't mean anything outside of a card instance. And so every card instance, it doesn't actually contain a copy of this data, but it contains a reference to the data. And so every card instance will be able to pull up all of the suit names and all of the rank names. Because he wanted to have ace being 1, he had to have an offset. So he has this none marker in here. You've got to be really careful about stuff like this, because when you do stuff like this, somebody eventually calls you up and says, I was playing your card game, and I had the none of diamonds. The truth is that if we're defining the card, we probably could have just defined it to where it took a string diamonds and a string of what its suit was. Or what its rank was. Okay, so here is his little diagram that indicates that he's got a card, and that it's got suit names and rank names, which are both lists, and then that's held inside the card type, but the card itself, its values are the suit and the rank. And so this would be sort of a diagram that kind of indicates the stuff that is scoped within the class. And this is a diagram that indicates the stuff that would be scoped within the instance. And so you can see the difference now. Remember you were talking about the template and the object? You can see how some of these things have different scopes. And that's the reason why I said that the suit names and rank names are not going to be copied into every card. They will be left at the scope of the class. Okay, and so here we are. He's got his jack of hearts, and there you go. So now, because of course we're talking about inheritance, there's no better time than to put in some more operator overloading. I swear, this is like, reading The Naked Lunch, where they cut up large portions of the book and just rearrange them. Or no, that's Breakfast of Champions. Yeah. They cut up large portions of the book and just rearrange them. It's a wild read, if you can go through it. So the point is that here he's going to override the less than operator. So he can basically indicate if a card is less than or greater than another card using the rank and the suit as values. And so here he says it's less than if the suit is less than the other suit, okay? But if the suit is greater than the other suit, then it's not less than. We'll return false. And so if once we get past here, since we have filtered out everything that's less than and everything that's greater than, the only thing that can get past here is if the suits are the same. And so then he says he'll return back the comparison of the rank. Does everybody follow that? It's a little programming optimization. I see a face that definitely tells me somebody didn't follow that. So what he's relying on is this early exit. So if something is not less than and something is not greater than, then the only remaining choice is it has to be equal. And so he's saying, here we get rid of all of the ones where the first one is less than the other one. Here we get rid of all the ones where the first one is greater than all of the other one. So by the time we get here, all of the suits being compared are the same. And so we'll just return back whether one rank is greater than the other rank. Okay?
The return doesn't have to be indented on the next statement?
Well, the return is in line with the block. So here is the definition, okay? And so to indicate that the return is part of this underscore underscore less than,
The other return.
it's indented. Which other return?
Yes.
Oh. So this is an if statement, and if you recall, the if, the condition ends with a colon, and then generally you would have an indented block underneath. But what he's done is he's used some syntax that he didn't introduce before, which is it is possible to put all of this on one line and it's still valid Python. Okay? And so he's just simply not indenting his returns underneath and making an extra block. So here you can see that basically after he went through this relatively complex early exit shortcutting logic, then he's going to say, oh, or you could do, remember that Python supports this comparison of arrays, of lists. And so it compares the first ones first, and then it compares the second ones first. And so he's like, or you can just define two temporary variables that have two values stored in the correct order, and then compare the two tuples. I don't know why he decided to present one and then just basically say that, like, after that, it's easier to represent it in a different way. But, I think he's just trying to remind you of the tuple comparison. Who remembers the tuple comparison? Okay, good. Yeah, you basically compare the first things, and if they're not the same, then you return whatever that was, and if they are the same, you compare the next things, and you keep going until you run out of things. So now that we've got a card, and we've got a way of comparing the cards, he says, okay, now it's time to make a deck, and so he's going to say if the suit is in the range of 4, so that means that we get suits 0 through 3, we get ranks 1 through 14, create a card for each one of those suits, and since cards is an array, we're going to add to the array each card. And so here this self cards was created to hold all of the cards, and he creates 52 cards this way, adding them to this array. Is that clear? It's kind of a nested loop way of doing it, but it works. And so he's going to declare a string method on deck. And it's going to say that we're starting off with an empty result array, and then for every card in the cards, we're going to append to it the string representation of the card, which will follow the underscore underscore str of the card, and print out something like 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, 6 of clubs, 7 of clubs, so on until it starts getting into the jacks and spades and whatnot. And here he shows right here that it's ace, 2, 3, all the way up to the king of spades. And so far we haven't even had anything inherited. So he's really building us up. He says, okay, now we're going to write some methods that allow us to pop a card off the deck and add a card to the deck. And I'm just going to keep moving along because basically these are ways of renaming the array operations. And he's saying that it acts as a veneer. You're kind of hiding that you're working with an array. You're starting to represent it as a conceptual deck of cards. And that's a very important thing to learn. But this is supposed to be a chapter on inheritance, and I want to get to the inheritance. And of course, no deck is complete unless you can shuffle it, so he added a shuffle definition to this deck. So this deck is actually starting to get pretty functional. Moving along. Yay! Inheritance, the 7th point in his thing. And so he's going to say that your hand is a type of deck. Now, he's using the word deck in a way that I would not normally use the word deck. A deck is a collection of cards, and he's going to say that your hand is a collection of cards too, and that would be pretty easy to understand. But a lot of people, when they hear the word deck, they're thinking like everything that comes in a deck that they buy from the store. He's abusing, in my opinion, this word deck by indicating that if you've got 5 players playing a card game, then you've got 1 deck on the table and 5 decks in each player's hand. Okay? Because he's really using deck as collection of cards. So assuming that you understand that he's using it as a collection of cards, we'll continue on with the example. But I would challenge you that if you were to write code like this, to come up with a better name that doesn't mislead. Okay, and so he says when you create a hand, you also can provide it a constructor. And so he basically says that he's got his own cards and he's got a label. And the label basically allows him to put a string to label this hand, which would probably be more functionally useful if it was like Bob's hand, or Steve's hand, or Kate's hand or something, but instead he's going full on less descriptive and just calling it new hand. Because obviously this will be the only new hand anybody ever has. Okay, and if you print out the hand label, it'll say new hand. And so here he is. He's going to pop a card off the deck, and he's going to add the card to the hand, and he's going to print the hand. Okay? And since he didn't shuffle his deck, it's going to print out the top card on a fresh deck, which apparently he believes is the king of spades. And he might be right for all I know. My card playing is not that good. And he's like, oh, but there's a way that we can actually not force people to keep track of the card being popped and added. We can add in a convenience routine called move cards, which will basically do the same thing, but it's attached to each deck. So now decks can move cards to other decks. The important part he glossed over right here. Okay? This part right here, this class hand parentheses deck. That's what this whole chapter should be about, because this is the time he actually inherited. This means that even if you don't type in your own definition for knitting it, or your own definition for the other functions, all of the functions that were defined in deck are usable by this hand. So that means that you can shuffle your hand now. You can add a card to your hand. You can pop a card off your hand. All right? And your hand has some sort of concept of printing out all of the cards in it. This part right here is the inheritance part. You already know how the dynamic dispatch works, so I don't have to tell you about that. So you know how the hand will eventually crawl its way up to find subs in the deck. All right, that's why I kind of felt like he introduced, in a traditional sense, the object-oriented ideas out of an easy order. And that kind of goes with Evan's observation when he was talking about other things out of an easy order. So anyway, here we go, and now that he's talked about that, he's going to say that sometimes object-oriented inheritance patterns are really hard to read when you're just reading them in text. And so there's other ways of representing them, and the other ways of representing them are with pictures. You know, if you can't explain it with words, try it with pictures. And so he's basically said that this drawing, which is a very simplified UML class diagram. If you're really keen on how to do these drawings in a very sophisticated way, read a document on UML and follow it. It's more complicated than it sounds. But this drawing shows that the hand is a subclass of deck. It's a specialization. It's a specialized kind of deck. And that the deck uses many cards. And so the stars mean some number of. The arrows that don't have the triangular arrowhead is a uses relationship in a class diagram, or a dependency relationship if you want to use UML's terminology more specifically. And this hand is a specialization or a subclass of the deck. Okay, and so this, I think, actually represents the relationships between the three items more clearly than the actual source code. But the problem is that this is a language, and you need to learn how to read the pictorial language. Okay? So usually when people are coming up with ideas and they're trying to figure out how the things are going to be related to each other, it's a lot faster to draw a couple of pictures than to write 3 or 4 different possible approaches to programming it. Because the approaches you've got to debug and make sure that they work. And the pictures you only have to represent the ideas. Okay, so do take a little bit of time to look through UML, but if you're not an expert in it, that's okay. And so these relationships of using, okay, or specialization, they have other names to them. And there's at least 3 sets of names that I can remember, and probably more that I can't. But what we're going to talk about is ISA and HASA, which is one of the early popular ways of rationalizing about inheritance. And so deck has a card, hand is a deck. Okay? And so that is the takeaway from his ISA and HASA relationships. And then the star indicates multiplicity, which means how many you're counting. Okay, and a star indicates basically, just like Evan's regex example, they overloaded and used the same idea. Star represents 0 or more. Okay, and there are ways in which you can draw 1.52 if you wanted to say that your deck always has to have at least 1 card in it and no more than 52. And so like here he's talking about a simple number if it's fixed items, and there if it's a range. And then of course he starts talking about debugging. And debugging is really a skill that you are going to develop as you wind up developing. You have to have bugs to learn the techniques of working them out. So it's not enough to just read this information or to understand it. by just writing a couple of examples. You've got to write enough examples to where you write bad examples. And then you have to figure out how to deal with bad examples. And preferably, if you want to really get into debugging, if you really want to stretch your chops, I suggest you go out to GitHub and find a Python project that they will list their bugs in GitHub, because GitHub has an integrated bug tracker. And just for fun, see if you can find out where it broke. Okay? A lot of bugs are written incredibly poorly. So sometimes there's not enough information in the bug description to figure out where it broke, but try. Now, data encapsulation. Data encapsulation is something that some people feel is absolutely required for proper object orientation, and other people feel is not required for object orientation. Remember, the guy that designed it said he wanted to get rid of data. Some people took that literally to mean you couldn't see the data. Okay? Other people meant that it was managed. Other people thought that he meant it was managed. He did not make a decision for many years. And then on top of it, he changed his decision twice. So all we can say is that this is a point of contention where if someone stands up and says, no, it absolutely means this, they might be right for a particular language, they might be right for a particular context, but there's no way of knowing if they're absolutely right. The idea is that if you have an object that holds some piece of data, and so let's say that this is a person object, and inside the person object, you have an age. Okay? And let's say that this person is at the age of 23. If all of your other objects read the age out, then you've got a problem. Because let's say that there is some sort of credit check policy that's based off of your age. And so you start putting logic in here to worry about the age. And then let's say that there's over here is like a data validation object that wants to make sure that your data sources are not messed up. And so it's checking for negative ages. Okay? And then over here you've got some sort of, like a spam filter that's trying to check that like the ages of the children are theoretically possible considering the age of the parents, to make sure that you're like not just having spam fed in through your sign-up process or something like that. And the point is that you're starting to put a lot of logic, and none of that logic is in the object. Now, if you wanted to figure out what was valid person age, what object would you normally open?
What was the valid person's age?
If you wanted to figure out what your policy was to determine a person's age is valid or not, which object would you open?
Company policies.
What if it's not a company object? What if it's not a company solution?
I have no idea.
The point is that the most natural object to open is the person object. Okay? This idea of putting the code next to the data, you tried to give him a -3 age. That's not going to be permissible. I'm sorry. People don't accept -3 ages. Okay? I don't care if you're a seer. No, the point is that the policy that's related to the object often should go inside the object. And so if you have your data directly exposed, and people are using it directly exposed, they sometimes start managing the data for the object in the wrong location. So data encapsulation, for the people who believe it truly should be hidden, their argument is that by hiding it, you have to force them to go through a function to get it. And if you force them to go through a function to get it, when it is time to update the policy, you can put the new policy in the function before you actually touch the data. So if you're setting a person's age, like maybe you designed a system in such a way that every year you have to go through every one of your customers and update their ages. Please don't do that, but people do. Okay? They're not great systems to work with, but people do. The point is that you can do that in many ways. And let's say you've got one of these broken systems that you're trying to maintain, and power goes out. Okay? On somebody's birthday. And you're going to be sitting there wondering, is 24 the age that they are now, or the age they were yesterday? And so what you can do is you can say, well, gee, I can't just make it based off of birthday because I don't have that information and I can't restructure this stuff. But if you had a function in front of it, you could simply say, we'll create a birth year object. And age will be calculated off of that. And we can calculate the birth year off of the age we've got right now. And you've got a way of working your way out of it. Now, if everybody was reading that age directly, there's no function to put that code in. You'd have to go and find everything that was using that and make sure that that validation code is everywhere else. And that doesn't sound like getting rid of data. That sounds like basically applying a policy across your entire programming suite. So the ideas of data encapsulation, even if the values are not hidden, are to try not to use the values directly unless you can guarantee they never change. Okay? Because then it's not a property of the object, it's a constant and invariant. You know, a property of, I don't know, the universe or something. So the point is that here he's going to talk about this data encapsulation, and so he's going to say that basically he's creating a Markov chain. Who knows what a Markov chain is? Congratulations.
Wow, that's good.
I think the rest of this is one of those math examples that shoots over the heads of your average beginning programmer.
I agree.
But a Markov chain is basically, if you've done a couple of things, what's the probability of the next things that might happen? Okay? If I let go of a pin, what's the probability that the pin will drop on the floor? It's pretty freaking high. Unless I drop it over the table. And so there's a slight probability that it falls on the table. And Markov chains, you can basically use them for updating the state of things and then reasoning about what the next possible states are. They're used in like gambling prediction systems and stuff like that. So he's using the wrong example, but let's see if we can still glean something out of it. No. Okay. So after he went through all of that description of data encapsulation, he basically gave you a poorly structured program and wants you to encapsulate the data with a Markov chain example. The point is that these suffix maps and prefix maps that are defined in it, you don't want to have these things exposed. So as long as you always reference the suffix map and the prefix inside definitions, and you never reference them outside of the object by just saying the object.suffixmap, then they will be effectively encapsulated, whether they are actually encapsulated or not.
Because you can't access and change them directly.
Yes, you can change them, but you would have to change them through defined function. Okay, because that would give you your window of opportunity to do some processing on it before it sets it directly. And that would be just enough encapsulation. Okay, so that pretty much covers objects. And they're not really that complicated. I know that we took most of the class going over it. The goodies cover little corner cases and stuff, and I thought that they'd make a nice sort of end of class wrap up. Evan, did you want to do the goodies?
I haven't actually reviewed the chapter, so I didn't know whether or not you were going to make it through it or not. I am cool with doing the goodies because I don't think we're going to have enough time anyway, and we do have one lightning talk.
Yeah, and that, I wanted to make sure that the lightning talks came into play. So, but I was really hoping that we didn't do the goodies because it's kind of like a completely different topic. It's all of the little Python syntax things that don't exist in other languages. For example, just to give you an idea of what kind of tricks we're talking about, this is an if statement. Normally in Python we said if x is greater than 0 colon math log of x else colon float not a number. But you can use this layout and get your entire if statement on one line.
I'm going